the AI Kubernetes Show.
Hello, and welcome to the AI Kubernetes Show, coming to you live from KubeCon in Atlanta. My name is William Chia, and I'm your host as we talk about all things AI and the intersection of AI, software development, platform engineering, Kubernetes, microservices, and all of the buzzwords. I'm very excited about our next guest, who is Keith Maddox, a senior principal software engineer lead at Microsoft. Keith is also a maintainer on the Istio project and is a co-lead for the Kubernetes AI Working Group. Keith, welcome to the show.
Happy to be here. Thanks for having me.
Well, I'm really excited to get your perspective because even though you yourself are a DevOps engineer, platform engineer at many different places, you work with a lot of folks that are trying to figure out the intersection of the data team, the platform team, the development team, and the changes in the AI landscape.
Absolutely.
What are you seeing in these changes and how these teams can interact with each other?
Well, that's exactly right. And when I think about my experience being a platform engineer, DevOps engineer in a medium-sized organization in the past, what we saw was that all of the different work that we were doing to bring Kubernetes to the company, to standardize metrics, observability, traffic management, all those sorts of things, we had one stack that we were shipping these to production with. But then our data scientists who are building models were in R or Python or any number of tools, MATLAB even in some cases. It's a very different stack. And productionizing that is going to be incredibly different than what we're typically used to. So today, when I'm working with customers, what we're often seeing is a little bit of a tug-of-war almost when it comes to who is going to own what that stack looks like? What are the tools going to look like when you're shipping data models to production? The platform team wants to stay with Kubernetes, all the Helm charts, all the very common stack that we might be used to. But the data science team does not want to change their workflow. They want to make a model, they want to iterate, they want to test new weights, and they want to see how it works in inference. And that's creating this dissonance in organizations across the world as they're all trying to ride this AI wave.
This is where this idea of even you're talking about like training, not just inference requests, running them off of inference, but
exactly
running training, experiment tracking, those kind of core data use cases. This is something that I've not heard a lot of at the show. Hear a lot more about running models for inference.
Sure.
But you have spoken with or talked with data teams that are looking to train models?
Yeah, absolutely. I mean, before you even run the model, you got to train the model. You've got to iterate. And so even when you're running things in inference in production, you want to be able to take the learnings that you're seeing and feed that back into a model. We call that oftentimes like reinforcement learning, where you've got models that you're serving in prod, and that model is sort of using that new information to get better and better at its task, is a sort of way oversimplified version of explaining it. And so because of that, getting the data scientists in the loop is extremely important. They need to be able to look at all their fancy machine learning, data science, AI, researcher metrics and information, and use that to make changes to this weight here or this transformation here in the data science, like in the model pipeline. And so because of that, there's a much larger influence that the data scientists have in these larger organizations than they've ever had before. Somewhat akin to when mobile was really popping off, right? You got your REST API, but then mobile engineers needed to optimize the asset pools or the server-side rendering of their mobile application and do that on the server. So I think every so often we have a new frontier where we are going to be doing work, doing programming, doing these infrastructure level things. It's going to be a new use case every few years. And right now we're here in that use case with AI, and Kubernetes has to adapt. That's why in the working group AI Gateway that you mentioned that I'm a part of, we're really thinking hard about, okay, how can we make sure that there's an end-to-end experience from the data scientist who is training the model, running inferencing, using that feedback loop to make the model better, and then their platform team who is running a fleet of Kubernetes clusters, who is fighting to try to find GPUs wherever they possibly can. How do we get a seamless experience and a seamless migration path from A to B? That's sort of the task ahead of us if we're going to keep Kubernetes to be the platform for running AI workloads.
That sounds very easy.
No, that was my boss's thing. He asked me for a status update.
just a light task there. Yeah, I'd love to dig in a little bit on some of the challenges of that end-to-end flow.
Yeah, absolutely.
But to poke a bit on the role of data science, this is something that we've heard a lot about here at the show, on the AI Kubernetes show, also in my conversations on the on the KubeCon show floor,
Right.
where I was chatting with someone about 30 minutes ago where their data science team was training their own models, run on their own GPUs, et cetera, and they recently just got rid of all of those, and they're only using foundational models from the hyperscalers.
Yeah.
And so I'm curious if you have any kind of like pulse on the trend of owning your own models, doing this type of data science, like experiment tracking, like reinforcement learning workflow, versus just pulling some type of generalized model from a hyperscaler and then just feeding it better context.
Well, I think we're going to see a sort of a long tail adoption path, and it really a hype cycle. I think today the power of foundational models has already been demonstrated. Like the past 3 years of LLMs and all the discussion with OpenAI and Mistral and Gemini and all those various things, we're already seeing how much value that they can bring. And so I think most organizations, when they're jumping in with the foundational model. They're saying, okay, data science team, I like what you've built, but let's see how much we can get out of these foundational models. But the cost to train those models and to make those better and better is so astronomical and is so high. You're really relying on a couple of really 3 to 4 companies, 3 to 4 labs to make those models and make them better. And for a lot of companies, that's not fast enough. It's not specific enough for their use cases. So what we're seeing in a lot of cases is this thing called transfer learning, or techniques where we do things like a low rank adaptation or LoRA adapters, where you can actually take a foundational model and make some tweaks to the weights in order to narrow it to your use case. So for example, you might have one adapter for a model that is very focused on English language responses. There's another that's on Spanish language responses, or another one for Chinese responses, because the weights are changed just enough so that the same foundational model that's been trained billions and billions of parameters can now be sort of adapted to be sort of specific for this one area or this one use case or this one topic. So that's one technique. You also have sort of transfer learning that can happen in the transfer process, where you take those embeddings and put them in a different context. So the data scientists have a lot of tools in their toolbox to make those things specific. And so I think because of that, we're going to see over time, right now we're in the super early adopter stage. Because of techniques for specialization, as well as data privacy concerns, liability, and the laws that are coming out about AI safety, because of that, I think we're going to see a lot more people, a lot more companies want to have very specific models that's a healthcare model, or a model for their HR system. Or maybe they use a foundational model that is using RAG, Retrieval-Augmented Generation, to get information out of their internal knowledge base and utilize that. Like there's so many different things. I think we're really only scratching the surface of what enterprise-ready AI is going to look like here in 10 years. And because of that, I think that the data science persona, we like to call it in Kubernetes, that persona is going to be critical, because again, what we're looking for is a smooth line from development to staging and testing to production, in the same way that we saw that with regular DevOps and shifting things left, and letting people run CI locally, in being the same CI, the same environment that's going to be put into production. We're going to see we're already seeing the exact same needs, the exact same requirements.
I like this a lot. One of the themes on the show has been the old is new, the new is old.
Yeah, absolutely.
Just as you would decompose the monolith into microservices, containerize it, so too, maybe once upon a time, the data science team was doing all their own ML, all their own model training. Maybe they're still doing training, but that looks different as transfer.
Right.
They're taking foundational models, adapting them. And I personally also believe we will see where these foundational models that can do everything are really powerful and impressive. But do you really need all of that for healthcare? Or wouldn't it be better if you had these specific things? So just like we used to have just one big thing and then we broke it up.
Right.
So too, data science will start to specialize into these segments.
Yep.
Which then adds complexity.
Yes.
Which then, in your job of trying to make the whole end-to-end thing work, makes it just a little bit easier.
Yeah.
So in this of course, I'm saying sarcastically, but in this end-to-end flow, this, the ideal state, where do you even start with such a complex problem? Like, how are you thinking about this as a working group?
Yeah, absolutely. So I hinted at it earlier, and the main thing that we're doing is we're thinking about this in terms of personas. We've done that with Gateway API for years, as long as we've been doing it. So we want to understand who are the users in our system and what are they trying to accomplish? What do they care about? And we literally can look at the PRs at the, for example, Kubernetes AI Working Group AI Gateway repository. You can actually see PRs where we're breaking out user stories and customer user journeys for people using our APIs. And doing that helps us, like in any other product, it helps us put ourselves in the shoes of the people writing the APIs. And so we've got a data scientist persona. We've got an inference platform owner persona.
Mhm.
We've got an application developer persona who is not running an inference workload, but is running a workload that needs to make an inference call. We've got all these different personas, and we're trying to sort of look at the big picture and make APIs, make hook points for each of those personas to be able to sort of affect the change that they want to see, to be able to affect their will onto the system. And really, that's our starting point, and we see where that takes us. Oftentimes it takes us a while because there's a lot of different use cases. But we start from there as a really core point, because if we can solve for at least one persona, we've added at least some value, right? It reduces the risk of us making an API nobody wants to use if we're grounded in the personas.
You're decomposing the persona monolith into, work on this stack at a time.
Exactly.
And you mentioned user stories. Within these personas, are there any kind of, for instance, or examples of this is part of the user story for a data scientist or for an application developer?
Yeah. So, for example, when I think about, I go back to again my history as a platform engineer. So, a platform engineer, I'm thinking about policy for my entire mesh. I'm sorry, my entire cluster. Excuse me. And so, because I'm wanting that policy to spread to any workload running in the cluster that I'm owning, then I want centralized places. I don't want an application developer to be able to overwrite my policy. So, for example, it's my boss, my VP is going to be getting on to me about our token rate limits, or our token limits for OpenAI or for our LLM provider. And so I want to make sure that there's not a single application that utilizes all of our tokens for a given month, because those are going to be budgeted. The price per token gets expensive for those LLM requests. Versus a sort of, not even a data scientist, but an application developer who is making a call to OpenAI, making a call to one of those LLM providers. They just are trying to do inference. And so they need something, they need me as a platform engineer to go in and have a policy enforcement point to say, no, you only get this much quota. So that as a whole, globally, we don't exhaust those limits or create a very, very high bill that my boss is going to be mad at me about.
Yeah, and then hopefully those app developers are, maybe they're also fanning out a whole series of agents that are then consuming more tokens, right?
Yeah, well, how much money do we have is the question.
But this is interesting. The idea of rate limiting the token spend. It's an old concept. We've been rate limiting. We've been setting quotas. We do this for cloud deployment. All kinds of things.
Yep.
And applying that old concept that we know well as platform engineers into this world of AI.
Yep.
Let's say I'm in an organization. I have the same problem as you. My VP says manage the global token spend.
Yep.
And set some reasonable policies. Any advice that you would offer to platform engineers in other organizations as they try to find the balance of giving their development teams enough context to do their job, but not blowing out the budget?
I mean, so I've got one technical suggestion and one non-technical suggestion. The technical suggestion is centralize the policy, right? As much as you can, again, I work with the Gateway API. We're working on ways to be able to say essentially have all the traffic for the cluster that's going outward flow through a gateway, and then sort of say, this is where we're going to check the token spend, and to make sure we can throttle individual applications if we need to. So versus trying to do it in every application, where if you deploy it over and over and over again, it's hard to keep track of it. You're relying on the application developers to do it. So centralize it. If you can through an egress gateway, it's going to be the best piece of advice technically for solving them. And then the non-technical advice, as someone who has lived in that world, is communicate, right? It sounds super simple, but your application developers are gonna be a lot happier if you give them a heads up about the token spin. If you have maybe an internal office hours to have them, request more quota for their service or for an event that they're having. A lot of times we as technicians, as people who are technical, don't want to get involved in some of the business things or some of the political things, but a healthy organization is going to really run when you've got open communication throughout the different parts of your organization, like any system, right? It's interfaces, it's APIs, same thing with people. And so if you can communicate with your application developers, you can help them to understand, okay, what are your needs today? What are your needs going to be in 6 months? How can you make sure you adapt our token spend to our token limits and quotas to adapt to those use cases? You're going to get a lot happier application developers and probably a healthier business overall.
I love the what I call customer empathy, or if you think of it as the developers in your organization are customers of the platform team.
They really are your customers. And that's the best way to think about it. And I think the organizations that do that tend to be the most successful.
Yeah, just even me hearing you speak where you're saying like, okay, I need to maintain spend, I've got pressure from this side, but the heart behind what you're saying of here's an engineer, they might have a normal load, but there may be something coming up where it's going to spike.
Right.
And you've given them an API, office hours, a human API,
yes,
to come and chat with you and just be like, let's have a conversation. That is, I think, some of the most spectacular advice out of all the technical things we can talk about. Having conversations with your colleagues and your team is
no substitute for it.
Never going to go out of style.
No substitute for having an open conversation.
Of course, in the world of AI, new kinds of challenges do emerge, even though you have the same old things. There are some things that are new.
Yeah.
And one of these new challenges is I, as a user, have a certain identity.
Yep.
I have a certain set of permissions and things I can do. But when now I'm delegating workloads out to AI agents, those agents have an identity. So whose agent is it?
It's a great question. Maybe we should start by just defining what an agent is for everybody. So when you think about an agent, the three things that I sort of think about are you've got an LLM that's able to think about and sort of interpret human language. You've got a loop. You're running that LLM in a loop and the second part is the loop. The third part is the goal. So it's an LLM running in a loop to accomplish a certain goal is really what an agent is, simply put. And so, yeah, like you were saying, when the agent is running in this loop and is doing this job, how do I think about that agent identity-wise in my system? Historically today in infrastructure, we sort of have two different categories. You've got machine identities, you've got human identities. And machine identities are thought about very differently and are expressed very differently than human identities. Agent identities are somewhere in the middle because it's going to be running from some infrastructure, maybe on behalf of a user, but if I've got an agent running for me, I don't want it to have all the permissions that I have. That's a security team's nightmare.
Yeah.
I want to scope it down and give it just the permissions that it needs, just in time, so it's able to accomplish its goal. And so, to be honest with you, from the open source specs I'm seeing, there's not a solid answer. People are working on it. We're aware of the answer, or aware of the question. And there are a lot of different options. Just-in-time registration with your IDP is one option that people have thrown out, where the agent has no identity to start, and then it requests an identity from the IDP using OAuth or something similar, an OAuth extension, and then it gets the identity and it's maybe time-bound for what it's doing. And then when the agent's, it's very... So typically machine identities are really short, like 24 hours. An agentic agent identity might only be 1 hour or 30 minutes, depending on the task. And so we're continuing to iterate within the broader software ecosystem and creating standards to describe this problem space, to describe how to think about agentic identity. And once that gets figured out, then we sort of downstream in the Kubernetes, KubeCon ecosystem need to figure out how to think about those agentic identities. How do we make those work in our system? Because it might not be very long until we've got users, we've got humans, and then maybe 30%, up to 30% or more of our traffic is going to be coming from agent identities. So we've got to figure it out, and it's going to be a really interesting question to figure out how to secure these things.
So absolutely, there is a lot that's not figured out yet, but of course, we're all still doing this today. I say we all are.
We're trying.
Are a lot of people just doing this today.
Yeah.
So absent of a nice specification and a set of standards, again, I'll ask your advice. It's been terrific so far. I'm a platform engineer.
Yep.
My org is saying we're going to run agents. My security team is pulling their hair out. And
Yep.
what can I do to help in that scenario under the constraints that I have now?
Great question. So there are a couple of different layers to look at this from. One layer is that a lot of your agents are going to be untrusted, or the agent's going to be running operations that are untrusted. A lot of time we're seeing agents spinning up containers, doing a job, or talking to an API. And so one of the biggest recommendations that I would say is look into agent sandboxing. There are some announcements this week at KubeCon about agent sandbox within SIG apps, and seeing how you can lock down the capabilities of an agent. There are technologies like Wazet, which is another open source project that allows you to run different agentic tools as within WebAssembly, and have sandboxing that way so that you can limit what things that tool has access to. And there are classics like gvisor and KVM and Docker capabilities, Linux kernel. As much as you can to get your agent isolated in its runtime, the better, because ultimately it's an LLM and it's unbounded and it's non-deterministic. So you want to keep a limit on what it can do. And then on top of that, security-wise, I would lean more towards machine identity in these early days. If you're going to give an agent an identity, make it a machine identity, make it to be something that is ephemeral, that needs short-lived as you can get it, and keep a track on the spec and see where it goes. But I think it's going to look a lot like machine-oriented identities.
If you have to err on one side, err on the short time to live, to cycle those identities.
Yes.
That will cause problems, but less than the long live.
100%.
And then again, we have this tooling and understanding and capabilities as a community to isolate workloads. We've been doing this a long time with a lot of different tools. And
how containers came to be was isolation.
This is what we're all about at KubeCon.
Right.
We've even chatted about WASM and WebAssembly isolation sandboxing. So these are really some great tips and advice on keeping everything small like a microservice, keeping it scoped, keeping the permission scoped, giving it a short time scope. Those are ways that you can mitigate risk today while still unleashing a immense amount of power.
100%.
And you then also mentioned that this needs all of this constraint due to its non-deterministic nature.
Yes.
So one of the challenges is, as software engineers in particular, we love an input has an output,
right?
But not quite how AI works. What type of mindset shift or advice do you have, not just for platform engineers, but software development teams in general, and how they need to think about their job in a non-deterministic world?
Oh man, that's a big question. I think as a whole, again, like you said, we're very used to pure functions. Thing comes in, thing comes out, and your function is sort of the output's predetermined by the input. With agents, we don't always have that. And so the way that I would say think about this is with an immense amount of suspicion. Don't think about what can go right. Think about everything that can go wrong. And if you start with that mindset, you're going to be thinking in the right direction. You're going to be thinking about, okay, how could a malicious agent get inside here? How could my agent get confused and something do prompt injection? Because at the end of the day, an agent's still just an LLM and it's susceptible to those things. How can I add guards in my infrastructure to say, oh, this is explicit content, don't send this back. Or this has an API key in it, don't send this back. All of those things are, those techniques come about because people thought about what could go wrong here. And so start from that mindset, and you're going to be able to, I think, go pretty far in stopping potential issues.
I really love this advice as well. Like much of what you said today, these are existing capabilities that we have in an engineering community.
Yeah.
Engineers tend to be skeptical by nature.
Yep.
And so double down on this core identity. If you're skeptical of most things, be a little bit extra skeptical of what the AI is doing.
This is zero trust at its core. At the end of the day, like you don't trust any of the machines that spin up. You might spin them up, you still don't trust them. And so take a zero trust approach to agents is my what I would say.
And just eke out those permissions a little bit, or even just thinking about all the ways it could go wrong.
Yes.
Will be a helpful mindset as we approach the way non-determinism can manifest itself.
Right.
Well, Keith, I've really enjoyed the conversation.
Likewise.
This has been a lot to chew on, and I think the audience will really enjoy digging into some of these concepts. For folks in the audience that want to connect with you online, where can they track you down and hear about what you're doing?
Yeah, so find me on LinkedIn. I am in a bunch of different Slack channels. I'm on Kubernetes Slack, CNCF Slack, Istio Slack, Envoy Slack, a lot of Slack channels. So find me on there. And then, of course, I'm on GitHub as well, at Keith Maddox. And, file an issue, reach out, and love to connect with you.
Keith, been a pleasure to have you on the show.
Absolutely. Thank you.
Created by the team at buoyant.io.